So sketching curves. Sketching curves is section 8.3. This is a really easy section. You are relying on creating a list of x and y coordinates to plot and then sketching it on the given restriction for t's. So over here we've got two equations. X is 3 cos t plus 4 and y is 2 sine t. T between 0 and 2 pi. So I went from 0 to 2 pi every quarter pi. The quickest way of generating this table is to go to your calculator and find the table function, which is number 9. And then it allows you to input two functions. So the first function I'll put in is 3 cos t. So instead of t, you put x plus 4. And then when you press equals, it allows you to put the second function. So you can have a set of two coordinates, sine t. Now you need to make sure that you are working in radians, because 2 pi suggests this is the question with radians. We're going to start from 0 and at 2 pi. So just put 2 pi, there you go. And we're going to go in step of pi over 4. So put pi divided by 4. That's what pi over 4 is. Equals. And here's our table. So the first value, and you can check it yourself. 3 times cos 0 gives me 3 plus 4 is 7. So that's correct. And then with that, my y coordinates, which are g of x on the table, that's 0. Then going across, always read the values down here in case you have to fill in the table and you round it, because this one is truncated, while this one will be, you should show more digits so you can round it. So this one here is going to be 6.12, and that's 1.41. And then you've got 4 and 2, and then 1.41 and 1.88, and then 1 and 0, and then you've got 1.88 and minus 1.41. See a pattern here. 4 minus 2, and then 6.12 and minus 1.41, and last values are 7 and 0. So came back to the initial position. Okay, so let's just plot these values. So the highest value of x, or the lowest one, is 1, the highest is 7. So if that's 1 here, 2, 3, 4, 5, 6, 7 will be here. The y values, the lowest value is minus 2, the highest value is 2. There you go. Let's plot the points. So 7, 0 is the first point, 6.1 to 1.4, so 6.1 to 1.4 is somewhere here. 4, 2, so it's 1, 2, 3, 4. 2 is over here, and you've got 4 minus 2 as well. And then you've got the same one on that side, so it's 1.88, which is over here, and 1.41 somewhere here. And then there'll be symmetrical to the other side as well. So there you go. Okay, so you can just sketch, join the points. Now, if you notice, the first one here was when t is equal to 0, so it's quite nice to see that t is a continuous function. So as t increases, you are traveling along the curve, and then the t's are getting bigger, but then you're coming back on yourself here. There you go. And then obviously if you continued after t equal to 2 pi, you'll be doing another rotation. So that one here is t is equal to pi, then you've got t is equal to 5 pi over 4, etc., etc. So we also asked to find the Cartesian equation of this curve. It looks almost like a circle. It's actually an ellipse. It's not the curve we study, but you can still be asked to find the Cartesian equation. So let's find the identity connecting sine and cos. So it's sine squared, t plus cos squared t equals 1. Now sine t is y over 2, and cos t, take away 4, divide by 3, so x minus 4 over 3. And you're nicely substituting these into our identity. Sine squared plus cos squared equals 1 is equal to 1. You can just write it, and normally you could leave it like that. Don't do any more rearranging because you will be able to make it less complicated. Here's example 7. Doing the same thing as we did in the previous example. Go to the table function, which was number 9 on the calculator. Input x equals 2t, y equals t squared, and you get to the table with the values. So ranging from -1 up to 5 for t. So when t is equal to -1, if you go to this one, you'll get -2, and y would be 1. That's the first point to plot. Then you've got 0, 0, then 2, 1, 4, 4. Let's have a look. 6, 9, and 6, 16, and lastly you've got 10, 25. So you're going to draw the curve of this, plot those points and see what curve we are going to obtain, and then we can confirm it by looking at the Cartesian equations. So my x's vary from -2 to 10, and the y's from 0 to 25. So if I go to 10, 20 along the y-axis, so x's are going to be, I need to go up to 10, so 2, 4, 6, 8, 10, and then -2 here. So let's plot these points. You've got -2, 1, so -2, 1 is over here, 0, 0, 2, 1, 4, 4, so 4, 4 is here, and 6, 9, so it's 6, 9 is over here, and that's not, I've copied it wrong, that was 8, apologies, 8, 16, so it's 8 here, and then 16 over here. Let's go to 15, 1 square lower, and then 10, 25, so 25 is over here. So on that restriction, this is the curve we are getting, the end point belonging to this. So it looks like it could be a quadratic because of the symmetry of those values. Let's just confirm it. So if x is equal to 2t and y is equal to t squared, make t the subject to get right. Okay, so substituting x over 2 into y equals t squared, we are going to obtain x over 2 squared. We actually met this graph before. It was a quarter of x squared, which is a quadratic. So you can clearly see that this is a quadratic function. Okay, so this means that you can go on to exercise 8c. But I strongly recommend that you watch the next video where I'm going to go through certain questions on finding the domain and range from parametric equations.